Hi, geometry students. Today we are going to be talking about cylinders, cones, and spheres. These are solids that are not polyhedra because they don't have every face a flat polygon, but they are solids. They are enclosing a region of space, and they do have some curved surfaces. That's what these all have in common. So, starting with cylinders, the definition of a cylinder would be a solid that has two parallel circular bases connected by a rectangle whose width wraps around their circumferences. Basically, the rectangular area wraps around the circumference like a label on a soup can to create the body of the solid. Okay. Now, the surface area formula comes from kind of pulling this apart into its net. The top and bottom are both circles. So as you know, surface area is composed of two different parts. The first is the walls, or the upright portion when it's sitting on its base, and that would be called the lateral area. In terms of a cylinder, that lateral area is made up of a rectangle, just like the label of a soup can. And the width times length of a rectangle, or base times height, like when we did parallelograms, those would correspond to the circumference of the circle for the width, and then the height of the cylinder is the height of the rectangle. So the lateral area right here is the circumference of the circle, 2 pi r, times the height of the cylinder. That's the lateral area. The area of the two circular bases is just area of a circle formula, pi r squared, and there are two of them. So the surface area is 2 pi r h plus 2 pi r squared. Kind of rolls off the tongue nicely. So here's our formulas. This is it kind of separated out, just lateral area, 2 pi r h, and then surface area, both parts together, lateral area plus the two bases. Okay. We are going to do some examples of finding surface area of a cylinder. Okay, so our first example, the cylinder has a radius of 6.6 feet and the height of the cylinder is 8.3 feet. Find the total surface area and the volume. Well, there's a volume formula right above, so we will use that too. But let's start with the surface area. Gotta get a better marker. All right, so here is the formula, 2 pi rh plus 2 pi r squared. We can identify from the problem that the radius is 6.6, so that's going to go in here. And the height of the cylinder is 8.3. So 2 pi times 6.6 times 8.3 plus 2 pi times radius 6.6 squared. Okay, I'm going to go ahead and work that out on the calculator. I would like you to do the same thing, and then we will compare notes. So you might want to stop at this point. Okay, I got 617.9. And since this is in feet, then surface area would be feet squared. All right, while we're here, we're going to try out the volume formula for a cylinder also. So here's the volume formula, pi r squared h, and we're going to put in 6.6 for the radius and 8.3 for the height. And this will give us the amount of space contained inside the cylinder, how much soup it could hold if it were a soup can. But this is feet, so this is much more like a small silo or something like that. Okay, I'm going to type it in as 8.3 times 6.6 squared times pi. I'm going to do it in that order. Actually, I might just do 6.6 squared first times 8.3 times pi, just to make sure that only the 6.6 gets squared, not the pi. And the answer that I get is approximately 1,135.8. Since this is volume, this will be feet cubed or cubic feet. It's a measure of space. Okay. All right. The next question we're going to do says the height of a cylinder is 12 centimeters and the surface area is 128 pi square centimeters. What is the radius of the base? So this is kind of asking us like a backwards question. So let's start with surface area formula. 2 pi RH plus 2 pi R squared. And the height is 12. So that's going to go there. And the surface area is 128 pi. Okay, let me just fill in the rest of the formula. Now notice that we are looking for the radius. So this, I'm going to put it in blue so it stands out. Radius is what we want to solve for. Okay, that didn't really stand out too well in the video, but we want to get R by itself. So first I'm just going to clean up a little bit. 12 times 2, that's 24 pi times R plus 2 pi times R squared. Over here I have 128 pi. Now, in order to get R a little closer to being by itself, I'm going to do a little trick where I divide the whole equation by something to get rid of some of the complexity here. You can divide a whole equation by the same quantity and it's okay. So in this case, I'm going to divide by, do you see a common factor that all the terms can kind of we just get rid of? It's going to be 2 pi. So I'm going to divide by 2 pi, divide by 2 pi, divide by 2 pi, and what I'm going to have is, let's see, 12R plus, this cancels out completely, R squared equals, and then what's 128 pi? The pi's cancel out. What's 128 divided by 2? 64. Well, this is a lot simpler of an equation, but it is still a quadratic equation. So the great news is that we are going to review quadratic equation in geometry so that next year when you get to Algebra 2, you haven't completely forgotten and not seen one in a really long time. So we're going to take this equation, 64 equals 12R plus R squared, and we're going to put it into a standard quadratic form, which is where all terms are on the same side of the equation equal to 0 on the other side. Okay, so I'm basically going to subtract 64. I'm going to put 0 here. I'm going to get rid of 64 by subtracting it from both sides. Okay, and I'm going to, on this side, these are my 3 terms. I'm just going to rearrange. I'm going to swap those 2 by the commutative property. And now I have a quadratic equation that I could solve by a number of different methods. Some people may want to use quadratic formula. Do you remember quadratic formula from Algebra 1? It's negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, if you're not really remembering that or you don't feel like going through that, the other option is to try to factor this. So let's think about, is there a way to split up this trinomial into 2 binomials that could be multiplied back together to get R squared plus 12R minus 64? Typically, we know that the term in the front of each parentheses has to make R squared when we multiply, so R times R. Then we skip to the back, and we're going to look for 2 numbers that when we multiply them, we get negative 64. But at the same time, we have to realize the outers plus the inners. Remember that FOIL, F-O-I-L? First, outers, inners, last. It has to work out that we could FOIL this back together and get our quadratic equation. So what 2 numbers can you multiply to make 64? that you could also add or subtract them to make 12. Let's see. Factors of 64. 1 times 64? No. 2 times 32? I'm just kind of going through like every possibility. No. 4 times 16? Oh, there we go. 4 and 16. If we put a negative, let's see, a positive 16 minus 4, then when you multiply them, you get your negative 64. But when you do your outers and your inners, you'll get 16r minus 4r. And there you go. So once we have it factored, we can set each factor equal to 0 and solve. Okay. On this side, getting r by itself, we end up with a negative 16, which actually I know cannot be the answer because you can't have a negative radius. But over here, we get r equals 4. So that must be the radius of this cylinder. I bet that was a surprise today, right? Okay, moving on to cones. A cone is a figure that has a base that's a circle, and then it has one lateral face that is a curved surface that wraps around the entire circumference of the circle, but it comes up to a singular point. So the cone formulas are shown here. The lateral area is the area of, here's the net. There's the circular base. This is the solid. So here's the net. It shows the circular base, and then this lateral area is what you'd have to cut out to create a cone. The area of that is pi times the radius of the circle base times the slant height. And in a cone, the slant height is similar to the slant height in a pyramid, where it's from the outside edge of the solid up to the vertex along a line perpendicular to that edge. So going straight up the surface of the cone, that's the slant height. And so that's your little L right there in the lateral area formula. Surface area for the whole thing would be pi RL, that's lateral area, plus the area of a circle, the base. So it's just lateral area plus one base. And then here's a volume formula for cones. How much can you fit inside the cone is 1/3 pi r squared h, where h is the height of the cone, not the slant height. It's the altitude from the center of the cone straight up to the vertex. Okay. So our first example, Stephanie saw this cat in a TP photo on Instagram. Now she wants to make one of these tents for her kitty, shaped like a cone with a height of 4 feet and a diameter of 5 feet. How much fabric would she need to create this tent? When you think about it, we could find the lateral area first, and it looks like the tent actually has a floor, so we could find the entire surface area and just the lateral area. We'll calculate them separately and then we'll put them together. Okay, so the lateral area is pi times radius times slant height. Now, have we been given the slant height of this TP? No, we actually have, for the cone, the radius is, the diameter is 5 feet. Diameter is 5 feet, so the radius is 2.5, and the height is going to be 4 feet. So in order to find the slant height, maybe I should make this a little bigger. Okay. Here's the cone. Here's the height of 4 feet. Here's the radius of 2.5. The height or altitude of the cone is always perpendicular to the radius of the base. So in order to find the slant height, L, we're going to have to use Pythagorean theorem. So I'm going to go off to the side and do L squared, that's the hypotenuse, C, is equal to A squared plus B squared. 2.5 squared plus 4 squared. All right, so L squared equals 6.25 plus 16 is 22.25. Take the square root of both sides. You get L slant height is 4.7. Okay, so that's what's going in for the slant height, and the radius is 2.5. Okay, so this is just lateral area. 2.5 times 4.7 times pi. And I'm using the pi button to get as accurate as possible. And that's 36.9 square feet. Okay, that's the lateral area. This would be how much fabric she would need for just the upright part of the tent. Now, if she also wanted to order fabric or buy fabric for the bottom of the tent, we would add to that the area of the circle. So that would be surface area. It's going to start with 36.9, the lateral area, and add pi times radius squared. Okay, so 2.5 squared times pi is 19.63. That's this part. Plus 36.9 is 56.5. So this would be the total surface area in square feet that she would need to get the whole tent and the bottom. All right, here's another question. Find the surface area and volume of this cone. This time we've been given the radius and the slant height. So that formula says find the surface area. That formula is surface area pi RL times pi R squared. I'm sorry, plus pi R squared. So this is lateral area plus the base. Okay. And so we have pi times the radius is 4.7 times the lateral area is, the slant height is 13.6. When everything's given to you, it's really just a plug and calculate type of question. Make sure you plug in the right things in the right places. The radius is 4.7. And I still recommend doing things in parts and writing down the intermediate steps so that you can save yourself from having too many typos in one problem, and just kind of keep an eye on knowing the answer makes sense. So I'm going to start with 4.7 times 13.6 is 63.9 times pi. This part is 200.8. That's my lateral area, by the way. And 4.7 squared times pi is 69.39. So add these together. And you get 270.2. And this would be in units squared for surface area. Now it says also find the volume of the cone. How much space would be in the center of this cone? So let's just peek at that formula. The volume formula is 1/3 pi r squared h. So you don't really have to think too much about this to do it. All you need is the radius and the height. We have the radius, it's 4.7. But wait, can I put the 13.6 slant edge there? No, this is not slant edge. This is the height of the cone, which has to be calculated from the slant height and the radius. So this is what we need to find, which is perpendicular to the radius. Slant height is 13.6. Radius is 4.7. Height is that. So we're going to have to do a little Pythagorean theorem. I think maybe I'll try to do that in this space that I have on the screen. Let's see if I can get this going neatly enough. Okay, so it's going to be h squared plus 4.7 squared equals 13.6 squared. This time I'm putting the h as a and 4.7 as b because the slant is the hypotenuse. So that has to be the part on its own over here for c squared. Okay, where you put the stuff in Pythagorean theorem matters. So I'm just doing a little calculation. 4.7 squared is 22.09, and 13.6 squared is 184.96. So h squared is going to be, I have to subtract 22.09 from both sides now. And I get h squared equals 162.87. And then take the square root of both sides to get h by itself. And so h, the height, is the square root of 162.87, which is approximately 12.8. Okay. Now that number is what I can plug in here for the height, 12.8. Okay. And so I'm ready to calculate. Notice that pi r squared, this is the area of the base. And then we're multiplying it by the height. But this is not like a cylinder where it's a bunch of circles stacked up. It gets progressively smaller. So the 1/3 takes into account, that's just how it works out. Somebody discovered that it's always 1/3 of what it would have been as if it's gone straight up like a cylinder. It's gone progressively smaller to a point, and it works out to 1/3 of what it would have been. Okay, so let's start with 4.7 squared times pi times 12.8. And then I'm just going to do divided by 3 instead of times 1/3, because dividing by 3 is the same thing as times 1/3. So I got 296.09 or 0.1. And this would be in cubic units because it's a volume. All right, the last solid we are going to talk about, this is the 5th one, is the sphere. The sphere is a solid that surrounds a center point. Every point on the surface of the sphere is equidistant from that center point. Okay. The surface area of a sphere is just 4 times pi times its radius squared. And the radius would be any segment drawn from the center out to the surface of the sphere. Okay. A volume formula here is 4/3 of pi r cubed. Okay. R cubed means raised to the 3rd power times pi, and then 4/3 of that. 4 times 4 divided by 3. That's what you can do. Now here's another concept. A hemisphere is like half of a sphere. It would be taking a sphere and slicing it right through the center in any direction. You would form 2 hemispheres. We know that as a geography term as well. When you look at an open hemisphere, okay, the exposed surface that would have been inside the sphere is called a great circle of the sphere. Okay, it's the biggest circle that you could form if you were to slice this sphere in any way, because as long as you go through the center, you're going to get the biggest possible footprint. When you were kids, did you ever cut open, like, say, an apple and then take it and stick it in some ink and make a print on the page, like using various fruits or potatoes as like stampers? Well, it's the same idea. If you were to cut open a circle and you wanted to get the maximum If you're going to cut open a sphere and you want to get the maximum circle, you would cut through the center, and that would be called the great circle that's exposed. Okay, so here is an example of why you might need to, at some point, calculate the surface area of a sphere. Here's a situation where a groundskeeper for a museum needs to polish the mirrored sphere sculpture once a year, and that is going to require some special chemicals. You got to calculate for the correct amount. So how much is the surface area of this sphere if it has a 6-foot diameter? Okay, so formula, 4 pi r squared. Surface area of a sphere, 4 pi r squared. The radius we've been given is not 6. It's 3 because the diameter is 6. So we're going to put 3 for the radius. Square that. 9 times 4 is 36. 36 pi is actually the most accurate answer for the surface area of the sphere, but as a decimal, 113.1. And since this is a surface area, it would be square footage. Okay. Example 2. This is a different question. Check it out while I erase my board. Find the volume of a sphere given that the area of its great circle is 201.1 inches squared. Okay, the great circle has an area of 201.1. It's just a circle. So if the area of that circle is pi r squared, and we know the area is 201.1, then what we can do is use that to figure out the radius of the whole sphere. So we're going to divide by pi to get r isolated. You know, that cancels out pi. 201.1 divided by pi is 64. Well, that's convenient because now we just have to take the square root of 64 to get r. So the radius is 8. Now that we know the radius, we can go ahead and find the volume which it was asking us for in example 2. So volume is 4/3 pi r cubed. So this is how much would be inside the sphere, how much space. 4/3 pi r cubed. All right. So I'm going to calculate, first I'm going to plug in an 8 for the radius, and I'm just going to show you the steps that I would use to calculate this. I would always do the powers first because order of operations, exponents. 8 cubed is 8 times 8 times 8. It's 512. Okay. Now I might do 512, times 4 times pi, and then divide that whole thing by 3. And that way I get my volume is 2144.7. And this would be inches cubed. The radius would be inches. The surface area was inches squared. The volume is inches cubed. Okay, now we've been doing volumes of these non-polyhedra solids because we're just going to basically see one example of a couple examples of each of those. But now let's get back to talking about those other two, prisms and pyramids, that we learned last time. And we didn't use their volume formulas. So today I'm just going to show you a couple volumes for pyramids and prisms, and then that'll be it for today. So the volume of a right prism is just the area of the base, that's your capital B there, area of base, times the height of the prism. The height of the prism is the distance between bases. Remember that prisms have two parallel congruent faces that are called bases. The fact that there are two of them, there's a distance between them. That's always the height of the prism. So that's your H. And then the capital B means the area of the entire base, one of those bases. Because it's like taking the base and stacking it up a bunch of times, so that's why you're multiplying times height. Because that's how many of them are stacked up. Okay. The volume of a pyramid is very similar to that, except as it goes to a point, instead of them all being the same square stacked up, making a prism, they're getting smaller and smaller and smaller until they reach that point. The factor of 1/3 is what accounts for that loss of width. Okay, it always just works out that if you know the height of the pyramid and you know the base, the volume is 1/3 of the area of the base times the height. So these are some practice problems to apply those formulas. Okay, find the volume of this prism. All right, the volume of the prism is just going to be the area of the base times the height of the prism. Now the area of these bases is going to be the area of what kind of figure? What kind of prism is this in part A? It's a triangular prism. So we're going to have to find the area of a triangle. So this is area of a triangle, which is 1/2 its base times its height. Now, it looks like this on the page, but this is a right angle. You can see it on the bottom triangle, and this is 3 and that's 4. So if we were to rotate this up to be on its base of 3, okay, and its height of 4, we're going to plug in 3 for the base and 4 for the height, and 1/2 of 12 is 6. So the area of the base is 6, and then the height of the prism is the distance between the triangles, which is 2 centimeters. So that is going to be 2. So we're looking at 6 times 2 is 12. And this would not just be centimeters for volume, it's going to be cubic centimeters. "12 centimeters cubed." Because the 6 is a square unit, and then the times another unit, 2, it's going to be a total of cubic units. All right, the next question. What kind of prism is this? What are the bases made up of? Each base of this figure is a trapezoid. And then the height, or the distance between the bases, is 5. So that's going to be 5, distance between bases. Okay, so let's do area of each trapezoid. Okay, I'm going to kind of put one out here as if it were flat. We're looking at it from above. The height of the trapezoid is 3 centimeters. The one base up here is 14 centimeters, and the other base, the other parallel line, is 6 centimeters. Now the area of a trapezoid formula is 1/2 the sum of the bases times the height. And that's because we're basically averaging the bases. and then doing 1/2 that times, well, this is like the average of the bases times the height. So 16 plus 4, 6 plus 14 is the sum of the bases. The height is 3. So we have 20. Half of that is 10 times 3 is 30. So 30 is the capital B in this volume formula. And 5 is the distance between the bases. So the volume of this trapezoidal prism is 150 centimeters cubed. All right, we have 2 problems left here. The next one is a pyramid. And the volume formula for pyramids is 1/3 area of the base times height of the pyramid. So let's see, have we been given everything we need to plug into the volume formula? Can we find the area of this base? It's just a triangle, and we've got a base and a height for that triangle. If you were to stand up that little triangle on the bottom there, on its right angle, you would have a 4 here and a 6 there. And so this would be base, and this would be height. For the area of a triangle formula, 1/2 base times height. I'm using lowercase b because it's just the base of a single polygon, not a whole solid. Capital B is the base of a solid, which represents an area. Okay, so 1/2, 4 times 6, that's 24. Half of 24 is 12. Okay, that's what's going in for B. And then the height of the pyramid is the altitude, and they've actually drawn it in there, that little red line, and they've labeled it as 9. So we don't have to calculate anything there. We're just going to do 1/3, 12 times 9. And we hopefully don't even need a calculator for this one, because 1/3 of 12 is just 4, and 4 times 9 is 36. But what kind of units are these? Meters. So if everything's in meters, then the volume is meters cubed. And the very last example for today is a square pyramid. You can tell the base is square because there are little red marks showing the equality of all 4 sides. So the area of that base is just going to be 10 times 10, or 100. And the height of the pyramid is thankfully labeled for us right down the center. That is the altitude or height of the pyramid. That's 12. So 1/3 of 12 is 4. 4 times 100 is 400. And that's centimeters cubed. Volume of the pyramid. Okay. So we have now been introduced to all of the solids, and we've seen not only their surface area formulas, but their volume formulas. We've tried to practice problems of each. You're ready to practice these on your own, I think. And it was nice spending this time with you, and I hope you have a great night. Bye.